So a really brief introduction to random sampling and drawing inferences about a population in grade 7 standards. So the standard 1, students are to understand that statistics can be used to learn information about a population by exampling a sample. They can make generalizations about a population from that sample, and that they're only valid if the sample is representative of that population. They need to understand that random sampling tends to produce representative samples and support valid inferences. So they need to learn that it's okay to make a random sample, and that that probabilities can be really close, but aren't going to be perfect. So some vocabulary that goes along with this. First of all, a population. The population is the group of people about which the information is to be gathered. So if you wanted to conduct a survey about what foods are being served in the cafeteria at a school, the population would be the entire student body being served. And it's not always convenient to survey an entire population, such as in the case of the national census. It's not very convenient. That's why they only do it every 10 years, and they try their best to find all of the people, and they also do random sampling. And in fact, random sampling ends up being more effective and a better representation of the population than actually trying to find every individual, because it's difficult. So there's different kinds of samples. A representative sample is a subgroup of the population that matches the general characteristics. So perhaps you choose to sample 10% of students. You would need to include an equivalent fraction of students from each grade and an equivalent ratio of male to female students, and of every type of subgroup that you can think of that would be potentially affecting the outcome of the survey. A convenient sample would be a subgroup of the population that's easy to collect. For example, every homeroom or something like that. And a cluster sample would be a subgroup of the population containing a common characteristic. Perhaps you sample only a certain grade level, and it would not necessarily very effectively represent the entire school. So something to work with students on would be what are the upsides and downsides of representative sample, convenient sample, and cluster sample. A voluntary response sample sounds great. You can send that sort of thing out to everyone. Perhaps you send an email to every student in the school, but the downside there is you don't necessarily get the entire population. You only get the population of those who are willing to take the time to answer a survey. This happens a lot in surveying. The best way to get a sample that is representative of a population is to do a random sampling. If you're conducting a survey, you might try to pick some of each type of group, like in a school, some athletes, some band members, some honor students, some of each different type. But the problem is when you intentionally try to sample like that, it's always easy to miss some subgroup that you don't intend to forget. So random sampling is always the best bet. A random sample is typically statistically representative of an entire population, even better than trying your best to choose. So random samples are valid to make what we call inferences or predictions about the characteristics of the entire population without having to measure every single item. So in 7th grade, one of the things that we practice is gathering samples of information, and perhaps each person in the class gathers a sample of the information, and then all of that is pooled. Each person would find the mean, and then we study the center and spread of all the means collected by all of the samples by all the students. And an inference can be made. If it's just one person making a single sample, then the inference is the mean of the sample taken. And the more samples taken and the larger the sample, the closer to the center or the mean we get. So a nice activity to discuss these things, discuss the differences in the method of sampling would be something like this. For example, call every 100th name in the phone book. Well, ask students, what type of population are you getting at if you do that? So an example answer here would be people with phones who also have their numbers listed. So what about survey people who come to the Vote Now booth at a high school football game? Well, you're getting the population of those who are interested in sports, particularly football, and people who are interested enough to stop by the booth. So not necessarily the population you're looking for. Asking every 10th student entering a high school football game. Okay, well, doing the randomness of every 10th student is an improvement on the process, but we're still only getting those who care to go to a football game. And you can answer some of these others as well. Another type of question to look at is this as an example. What conclusions can be made from a study? So here we have a study at the University of Iowa in 2008 concluded that children that play violent video games are more aggressive in real life. The study was children ages 9 to 12. They were studied to determine how much they played violent video games, and then peers and teachers were asked how much these students hit, kicked, and got into fights with other students. So first of all, can you legitimately conclude from this study that teenagers who play violent games tend to be more effective? And then why or why not? Well, it's all in the details. What we see here is that the question was asking about teenagers, and the study was referring to children ages 9 to 12. So this does not match. No, we cannot make that conclusion. So B, can we conclude that children ages 9 to 12 who play violent video games are more likely to commit violent crimes? Why or why not? Well, I'd say no. The study does not talk about criminal records or violent crimes. So no. And then C, can you legitimately conclude from this study that children ages 9 to 12 who play violent video games tend to hit and kick more in school? Well, yes, there is evidence of a relationship here. So yes, you could make that conclusion. And then D, can you legitimately conclude from the study that playing a lot of violent video games will cause 9 to 12-year-old students to become more violent at school? Not necessarily. Was it, in fact, the behavior of the student that drew them to the video game? At part C, we can talk about a relationship, but there's not really a cause or anything specific. So, good discussions to have with students. That is it for this week. I hope you all have a great week, and please feel free to send me any questions, comments, as you're working through this. I hope you all are doing well. Thanks.